Today's episode number 9 is Let the Glass Be With You. It's a discussion of fiber optic cable and connectivity. I'm Kerry Rose, Industrial Channel Account Manager for the Southeast. With me again today is Marty Reagan, Industrial Channel Account Manager for the South Central, and Nick Weissong, Technical Sales Engineer for the Southeast, South Central, and West. We've now completed our building block series. We've discussed standards and how best applicable standards build a robust network. Today, we start the detail of what's selection of media connectivity types with respect to fiber. Next slide. In the past, we talked about fiber as a part of the structure of cabling plant system. Well, there's some advantage to having fiber in your facility. First, the glass is not affected by noise, both EMI and RFI. If you need faster resiliency or recovery, fiber is an obvious choice, especially if you want to be under the 100 millisecond range in terms of like a rep ring recovery. Fiber optic cabling length distances exceed copper's cabling reach of 100 meters. Fiber is a great media for outdoor applications or between buildings. Fiber is the backbone of choice for switch connection. And today, it's easier than ever to install fiber optic cabling. Actually, copper cabling is more susceptible to damage or performance degradation when improperly installed. Example, the maximum pulling force for a Category 6 cable is 25 pounds, where a standard distribution fiber is around 200 pounds. Next slide. Fiber is the backbone of your network. So you want to make sure that the backbone is capable of handling the growth of your network and the potential topology changes that may come. Of course, it's inevitable that technology will change. One of the biggest things you can do for your fiber infrastructure is to build a robust pathway. This will help protect your investment in the fiber backbone. There are two types of fiber optic cables, single mode and multi-mode. There are two versions of single mode fiber, OS1 and OS2. OS2, highlighted in red, is the preferred fiber for the industrial plant environment. The differences between OS1 and OS2 is not so much the difference in glass, but difference in construction. OS2 fiber tends to be outdoor rated or set up for harsh environments, whereas OS1 is more of an indoor rated fiber. Chief advantages of single mode fiber is that it supports longer distances, higher bandwidth, and the fiber itself is lower cost. However, it does have a higher total system cost when compared to multi-mode systems. Multi-mode fiber has gone through some changes over the last 20 years, starting with legacy OM1 fiber. And now today we really standardize on OM3 and OM4, which have been designed to be used with vertical cavity surface emitting laser technology. And we can support distances of 1 gigabit for up to 500 meters, or we can go 2,000 meters for up to 100 megabytes on an OM3 or OM4 multi-mode fiber system. Multi-mode fibers have a lower installed cost versus single mode, but the fiber itself actually is more expensive. Cable type is generally classified in two groups: tight buffer and loose tube. A tight buffer is actually a buffer or insulation annealed to the glass of fiber itself. And a loose tube is exactly that. Fibers in a tube that are loose, but the tubes typically have some type of water blocking gel in the tube to protect the fiber. Tight buffer configurations are more for indoor applications, and loose tube configurations are for indoor, outdoor, outside plant installations. There are two basic termination methods: mechanical and fusion splice terminations. The preferred connector being used today is the LC connector, the latching connector. The LC connector with a small form factor supports high density distribution of fiber. It also works well on small industrial switches. There are two termination methods, though. We have mechanical, which is where we actually are abutting two pieces of glass together within the connector and mechanically connecting them, and fusion splicing, where we use a tool that will actually arc and melt the glass together. In this case, we're connecting to pigtails. So I'm going to turn it over to Nick now. Nick's going to go ahead and highlight how these are distributed throughout the layer.
Thanks, Gary. The proper fiber is critical because it is the backbone of your network and is going to be the conduit between levels. If you don't have the proper fiber in place, you're putting your entire network at risk of data loss, and troubleshooting can be almost impossible. We talked about the various solutions that Panduit offers to house the equipment needed on the factory floor, but this is the first time we are going to talk about how to get that information to the edge device. In the scenario I'm showing, it is determined it was determined that we used single mode fiber from the main enterprise data center to the MDC, and then multi-mode fiber from the MDC to the IDF. We have also chosen multi-mode fiber down to the zone level. This is a typical scenario because single mode can reach longer distances that are usually between the main data center and the MDC. Your devices between the MDC, IDF, and zone are not usually as great. Some customers choose to stick with single mode throughout the solution, but this can drive up cost. So to keep the solution more cost effective, we've chosen to use a multi-mode scenario down to the edge device in this situation. The MDC and IDF are pre-configured solutions because they come with the basic building blocks you need to build up your fiber system. They use traditional enterprise fiber enclosures that are housed inside the robust cabinets. With the base enclosure, you can add several different types of adapters or Panduit's HD fiber cassettes. Based on the requirements of the installation, you are not limited to just fusion splicing or mechanical connectors. As we move down to the pre-configured zone, we start to get into those harsher environments, and we also have products that will work in those areas as well. You still get the flexibility of being able to use fusion splice or mechanical connections. The 8-port DIN mount patch panel works great when you don't have the larger space for the 19-inch rack mount enclosure. There are also options for a 6 or 12-port surface mount box to house your fiber adapters. If the application calls for fusion splicing, we have a stackable holder for the HD fusion splice cassettes as shown in the lower right-hand corner. Marty?
Thank you, Nick. As Kerry and Nick discussed, there are several types of both single mode and multi-mode fiber that can be deployed based on application requirements. Fiber optic cabling in an industrial environment can encounter all levels of mice, and attenuation or signal loss due to sagging and bend radius violations are some common installation problems. Therefore, the pathway and mice factors must be addressed during the physical layer planning. Cable tray provides closely spaced support and is used with indoor type fiber cable. Waterfalls and intersections can easily be incorporated into the pathway to protect bend radius. Conduit provides continuous support for indoor type fiber cable. It's an excellent safeguard for a fiber pathway, but fittings, junctions, and breakouts can pose a challenge during pulling. Finally, we have J-hooks with bend radius control built in to provide spacing support at 4 to 5 foot intervals for metal armored type fiber cable. The armor provides the needed rigidity to prevent cable sag. We'll have more discussion on these supporting products in episode 12. But in this slide, looking left to right, we're distributing various fiber types from the enterprise space to a micro data center and 3 industrial network zone enclosures in a switch ring topology. At the top left, wire grid cable tray is supporting OM3 high bandwidth distribution fiber secured with hook and loop cable ties. Side walls and waterfalls support bend radius and the turn down to the micro data center. From the micro data center to the first network zone enclosure, OM3 standard distribution fiber is deployed with conduit as a supporting pathway. From this network zone enclosure to the subsequent network zone enclosures, OM3 interlocking armor fiber is deployed with J-hooks as a supporting pathway at 5 foot max intervals. The high availability switch ring is completed with the same fiber type via cable trough back to the micro data center. All the fiber components Nick mentioned, fiber tray, fiber adapters, LC connectors, patch cords, surface mount fiber boxes, and slack management are all part of the standards-based structured cabling deployment. Next. In this episode, we discussed the fiber cable and the connectivity supporting the architecture throughout all cabling subsystems. We will continue with the TIA model next time as we deploy copper cable throughout the cabling subsystems to support the connected devices within the architecture. Next. Thank you for joining today. Join us for episode 10 as we discuss the copper cable and connectivity. Please feel free to share these short recordings and reach out to your local territory account manager or contact one of us directly if you need further assistance. We will also post this on our LinkedIn pages as a format to share as well.